In this short video, we're going to look at the key component parts of SIMS by Quinn, our super insulated masonry solution. The solution comprises of two key component parts. On the inside, we have our masonry substrate, which is our Quinn-lite thermal block, and on the outside we have an external insulation and render system. We'll begin by looking at the masonry substrate. Here we have a Quinn-lite 7.5 Newton thermal block. Building a masonry substrate using a thermal block or Quinn-lite thermal block offers a number of key advantages. Firstly, if we look at construction costs or labour costs, the block being 9 inches wide by 9 inches high, essentially you're cutting the number of blocks you have to build inside in half. Traditionally, if we talk about a 9-inch block using 9-inch wall using dense blocks, we build two 4-inch blocks in the flat. Here we've essentially replaced two 4-inch blocks by one 9-inch block. Equally, if we're building a cavity wall construction, we have two 4-inch blocks side by side. So construction time on site is reduced in half. Secondly, one of the key benefits obviously of the Quinn-lite thermal block is it's a low thermal conductivity block. Its thermal performance is almost 10 times that of a dense concrete block. So by using a Quinn-lite block as the masonry substrate, you're automatically improving the U value of your wall. And the third key benefit then is thermal bridging. Again, using a low thermal conductivity block as your masonry substrate, you are dealing with your thermal bridges throughout your house. All the junctions, the thermal bridging in the junctions is taken care of almost by default. So those are the key benefits or reasons why it's important in this solution to build a masonry substrate using a Quinn-lite thermal block. In this particular example here, we have decided to use a traditional sand and cement mortar to build the blocks, which is a good system to use. It's traditional and it's what a lot of block layers in Ireland are happy to use. Thin joint mortar is also another option for using for building Quinn-lite blocks. Thin joint mortar increases the bond between the blocks. It's a 10 Newton mortar, so it gives a stronger bond, which makes the overall wall panel much stronger. So much so that a 9-inch Quinn-lite block built with thin joint mortar is almost 3 times stronger than a 350 wide traditional dense block construction. So thin joint mortar, it does add strength. If the block layer is used to it, it can also add speed, but the key one there is strength. Again, an option if you're using thin joint mortar, due to that increased bond strength, it may be a possibility to reduce the thickness of the wall from 9 inches possibly back to 6 inches, which will again save costs on site. So the second key component part of SIMS by Quinn is the external insulation system. There are currently 20 NSAI approved external insulation systems in Ireland, and any of those can be used in conjunction with the Quinn-lite masonry substrate. So quite simply, the external insulation system includes an insulation layer, and then it includes a build-up of layers on the outside of that to provide your water tightness and your render finish. I suppose traditional blockwork in Ireland was cavity wall construction, but as advancements in material and technology took place, waterproof renders were developed, which basically replaces your outer leaf blockwork. So we've done away with our cavity, we have our insulation fixed to the Quinn-lite thermal block, and we've put a waterproofing layer on the outside of that. Here the insulation is a Quinn-lite pack pearl insulation. 140 mm thick on this example gives a U value of 0.18 through that wall construction. We're not limited to the thickness of this insulation. That's one of the beauties of not putting insulation in the cavity. Oftentimes in the cavity you're restricted with the amount of insulation you can put in there based on the thickness of your cavity. Here we can have insulation, this is 140 as I said, that can be out to 200 mil or whatever thickness you need to meet the U value you're looking for, or your target U value. So here this wall construction achieves 0.18. So we've looked at the two key component parts of the solution. Now we'll look at how they're constructed on site. So basically the masonry substrate, the quinlite thermal block, is built by the block layer, and when he's complete then the roof is installed and the windows are installed. The location of the window in relation to the quinlite block and the insulation is quite important. The further the window sits outside the quinlite block, the better the thermal performance. Here we've chosen to have the window sitting about 40 mil on the quinlite block and it's 30 mil external to that. That means that the window is supported off the blockwork. It's also an option to have your window supported completely external to the quinlite block, supported on brackets. And as I say, the further the window is out into the insulation, the better the thermal performance of that junction. So once the windows are installed, it's time to start the external insulation system. So the first process is to put on your starter track, and this takes place or is put on at the bottom of the wall, usually your plinth level. So basically that will be fixed into your quinlite blocks and kept level, and then that gives you a platform to start your insulation on. The insulation can be fixed using mechanical fixings. This is a thermally broken mechanically fixing. Different system providers will have different fixings, but essentially they're all going to be similar to this. So this is essentially fixed through the insulation into the quinlite block. Another option to fix the insulation is adhesive. So basically the adhesive comes in a bag, you mix it up with water and apply it to the back of the insulation, and then just put your insulation against the block and plumb it, and that will take a strong bond then with the block, and in some cases no fixings are required. So once the insulation has been installed, once we get up to window level, we have to put in our sill. In this example we've chosen to use a passive sill which is manufactured in Cork. The passive sill is essentially a high density polystyrene insulation coated with a resin, a strong resin, for aesthetics and durability purposes. As you can see there, the upstand on the sill sits nicely up behind the drip on the window, which weatherproofs that junction well. At this junction here we will have a seal tape which expands when wet and will prevent water ingress at that junction. The other option for a sill is an aluminium sill over a passive sill, but as I say, in this example we've chosen to go with the passive sill, which gives a very good thermal performance through that junction, essentially eliminating any thermal bridge. So once the insulation has all been fixed in place, it's time to start putting on the beads. On the starter track, this bead here simply clips onto the track as shown. So that gives the bead to start rendering up. Around all your openings then you have what we call a seal bead, and this prevents water ingress around windows. Basically it's got an adhesive strip on the back of it, and it sticks against your window frame and seals that junction and gives then a bead for plastering too. Once that's installed in place, you come along then and put on your corner bead. So again, your corner bead simply sits on there, overlaps the seal bead, and that's your corner bead in place. So once all the beading is in place, it's time then to render the main part of the wall. So the render system comprises of three components. You have a reinforcing mesh, which is this product here. It comes in rolls and it's rolled out over the entire insulation. And just as you're rolling that out, then you trowel on a base coat, which will hold that in place and also gives a base coat or a key coat for the final render solution to adhere to. So this mesh is rolled out over the entire wall and a base coat troweled across it. At some then of the high stress points, like the corner of windowsills as such, a second square or patch of reinforcing mesh will be put on at an angle at that location, and the same at the lintel above the opening. So depending on the system then, or the installer, once the mesh has been put in place and the base coat has been put across it, some of the installers then will put a fine second coat of base material across that, and then it needs to be finished very smooth to give a perfect substrate then for this final render coat to go on to. Now the render coat, there's a number of options. This is an acrylic, highly waterproof render that goes on here. There's also silicone type renders and Mannok type renders. So once your base coat and your mesh is in place, then the plasterer will either spray on this acrylic coat or trowel it on, and that is your final finish. Other options for finish, you can get this with a coarser grain sand in it to give a slightly rougher finish, or some of the system providers also will have a dry dash option. So essentially that then is your external insulation system complete.